Dear students, in the class we are going to discuss the multiple integral introduction part 2. So in the last class we have discussed about that the multiple integral when all the limits are constants. So what are the steps I have explained for the double integral? How to calculate the double integral? For the double integral, if all the limits are constants, first you have to draw the rough sketch and then you have to draw the parallel line to the inner integration axis. From the region, you have to write the limits for inner integration and then you have to write that the limits for the outer integration in the intersection from the intersection points. I have explained clearly step by step in the last class. This class we are going to discuss in case the limits of x or y are functions, the other variable limits are constant. Okay, fine. Case 2, what is the case 1? Case 1 is all the limits are constants. Case 2, if y limits are constants and x limits are variables. Y limits are constants and x limits are variable means, as I told, the inner integration limits may be that variable or constant, is it not? So if x limits are variable mean that should be that inner integral. What is the inner integral? Inner integral is with respect to x, is it not? That is clear. Now consider the double integral. I equal to integral over y equal to c, y equal to d, x equal to g1 of y, x equal to g2 of y, f of x comma y, dx dy. This is the given double integral. Then for this, first you have to draw the rough diagram for this. Rough sketch. What are the limits of y? Y equal to c, y equal to d are the constants. So here you can see that y equal to c, here we can write it is y equal to c, and then y equal to d here. So what is the point of this value? 0 comma c, x equal to 0. Here also we can write 0 comma d. But the limits of the x are the functions of y. The limits are the functions of y. Then how can we draw that the function for this? Here this is the first one, x equal to g1 of y, x equal to g2 of y. So x equal to g1 of y, x equal to g2 of y are the limits of the x. What is the first step? You have to draw the parallel line to that inner integration axis. What is the inner integration axis here? X. X is the inner integration axis. So draw the parallel line to x axis. Draw the parallel line to x axis. If you draw the parallel line to x axis, see in the region it is starting from x equal to g1 of y and then x equal to g2 of y. End with that x equal to g2 of y. Okay. So here see that x varies from g1 of y to g2 of y, y varies from c to d. So these inequalities determine a region in xy plane. What is the xy plane? This is the xy plane which contains that the x and y coordinates. So what are the points of A here? How can you write the intersection point here? First you have to write x, then you have to write y. What is the x value here? X equal to g1 of y at y equal to c. So that means g1 of c, comma c. Is it not? That is the intersection points. Similarly, D is, that is the x equal to g1 of y at y equal to d. That means g1 of d, comma y equal to d. Is it not? So what is this integration points? This integration point is x equal to g2 of y at y equal to c. That means g2 of c, comma c. The last one we can say what is a, b, c, d. What is the point c here? g2 of d, comma d. What is the region here? A, B, C, D is a region. A, B, C, D is the region. First you have to draw the parallel line to that x-axis. To write the limits of the x-axis from the region you can obtain. But to write that outer integration limits, how can we write that? We have to take in the axis. In the axis we can see that what is the values of y, c to d. So you have to write that the limits c to d, g1 of y, g2 of y. Whereas it is not like that the previous case. What is the previous case? All the limits are constants. If all the limits are constant, simply we can change the order. But in the double integration, if the limits are variables, we are not able to change the order. That means integral over c to d, integral over g1 of y, g2 of y, f of x comma y, dx dy is not equal to integral over g1 of y, g2 of y, c to d, f of x comma y, dy dx. That means you are not able to change the order if the limits are variables. Okay. Then we can see that the third case, case 3, if x limits are constants and y limits are variables. If y limits are variables means always you know that outer integration limits should be constant and inner integration limits may be that constant or variable. Therefore, if y limits are variable means the inner integration is y. Inner integration with respect to y. Are able to understand? So consider the double integral I equal to x limits are constant a to b. So x equal to a and x equal to b. Therefore, see here what is the inner integration y. So you can write here y equal to pi 1 of x, y equal to pi 2 of x. For the given integration, we can draw a rough sketch. That is, this point is a comma 0. This point is b comma 0. Okay. So we can write the points, the intersection points. How can we write the intersection points? What are the points of the intersection? A is the pi 1 of a. Oh, sorry. First you have to write that x na. So a comma pi 1 of a. What is the point b? B. First you have to write x value. So b comma pi 1 of b. Similarly, we can write that the point D and C. What is the point D here? Point D is a comma pi 1 of A, not pi 1, pi 2. Is it pi 2 of A? C value is B comma pi 2 of B. Very important thing is you should know how to find the region and how to find the intersection points. See, for example, in case you have to find the intersection point of, in case the region of integration is the region of integration is x square equal to y and y square equal to x. So how to identify the integration of region and how to write the limits for this? Very simple. So here two curves are given. What are the two curves? Two curves are parabolas. So x square equal to y and y square equal to x are parabolas. Is it? So draw the rough sketch for any given problem. First you have to draw the rough sketch for this. What is x square equal to y? X square equal to y. This is the x square equal to y. Y square equal to x is this one. Y square equal to x is this one. Okay. So x square equal to y, y square equal to x. How to find the intersection point? This is the intersection point. Here we can easily write that O 0 comma 0 origin. But you have to write that point A. How to identify that point A? Here given that x square equal to y and y square equal to x. Is it not? Y square equal to x. Squaring on both sides, x power 4 equal to y square. Substitute the y square value here, x power 4 equal to y square equal to what? X. Is it not? Substitute here. So x power 4 minus x equal to 0. Taking outside the text here, x cube minus x equal to 0. Either x equal to 0 or x cube equal to x. Sorry, not x cube minus x cube minus 1, is it not? So x cube equal to 1. So when x cube equal to 1, x is also x equal to 1. But what is the value of y square? Y square equal to x, is it not? In case y square equal to x means y square equal to, what is the value of x? 1. So y equal to plus or minus 1. But plus or minus 1 is there, but here it is a first quadrant. It is a first quadrant. For the first quadrant, y is always positive. Therefore, we can take that y equal to 1. When x equal to 1, y equal to 1. Therefore, this intersection point is 1 comma 1. So this value is 1 here, and then this point is 0 comma 1, and then here we can write this point is 1 comma 0. But what is the region of integration? How to identify the region of integration? So how to identify the region of integration? We can see that I equal to double integral over f of x comma y dx dy. Okay, you have to identify the region. How to identify the region? What is the inner integration axis here? X. So draw the parallel line to x. Draw the parallel line to x. If you draw the parallel line to x, the region between, what is the region here? The region is lies between that x square equal to y and y square equal to x. Is it two parabolas within this parabolas? So here it is a region. If you draw the parallel line to x, see in the region is started from this parabola and end with this parabola. So therefore, what is this parabola? First parabola. First parabola is y square equal to x. Y square equal to x. But you have to write in terms of x, is it not? So x equal to either y square equal to x or x equal to y square. So x equal to y square to end with here. That means x square equal to y. Yeah. So in case x square equal to y means x equal to plus or minus root y, but it is in the positive side, therefore we can take only the positive value. So x equal to plus root y. So this is the way to write the limits of the inner integration. Next we have to write that the limits of the outer integration. How to write that the limits of the outer integration? As I told that, see the intersection points. Two intersection points are there, 0 comma 0. Very simply you can write that the outer integral limits. What are the intersection points? Take 0 comma 0 and what is the second one intersection point? 1 comma 1. Is it not? From this you have to identify what are the that is you are going to write that y coordinates. Is it not? So simply you can take the values of y. That is enough. No need to consider that x here. To write that outer integration, simply what are the values of y you have to write. Isn't it? So what are the values of y here? Y values are y equal to 0. See that here, y equal to 0 and y equal to 1. I repeat that when you are writing the inner integration limits, you have to see the values what are curve in the region. To write that outer integration, no need to see the region, whatever the region it may be. See the intersection points. What are the intersection? Two intersection points are there for the two limits. From that you have to choose that what is the value of y. That is enough. Okay. So this is the procedure to write that inner integration limits and outer integration limits. Simply you are not able to change the order for this integration, but you can change the order under some conditions. What are the conditions? What are the conditions? Listen, in case if you are changing the order, what happen? If you are changing the order, for example, if you are changing the order, if you are changing the order mean I equal to double integral f of x comma y. That is, in the place of x you have to write y, in the place of y you have to write x. That means dy dx. Is it not? Now, so previously the inner integration x, now that inner integration is y. For that inner integration is y, you have to draw the parallel line to inner integration axis. You have to draw the parallel line to inner integration axis. So this is the inner integration axis y. Draw the parallel line to y axis now. So what is the starting point when you are draw the parallel line to inner integration is axis parallel to y axis? It is starting from here and ending with here. Okay, so what is the y value here? This is okay, this is x square equal to y or y equal to x square. Starting with this is x square equal to y na. So y equal to x square, starting with y equal to x square and end with this curve. So what is this curve? This curve is y square equal to x. Is it not? So therefore y equal to plus or minus root x. So y equal to plus root x, as I explained this, and then simply we can write that values of x. Now already we have taken y value in that integration. Is it not, sir? In the limits. So what are the intersection points? 0 comma 0, 1 comma 1. Okay, so now we have to choose only that x value. What are the x value now? 0 and 1 are the x value. Therefore the limits are 0 and 1. This is a procedure to write that the limits of the integration. Is it clear? So, in case, how can you identify the given integration, the double integral is proper or not? Even in the examination, if they are given in the wrong order, we have to change in the right order. For example, I equal to integral over 0 to 1, integral over x square 2x f of x comma y, f of x comma y dx dy. In case they are given, very simply you can identify, in case the inner integration is x, the limit should not contain the x, it should contain that opposite, that means it should contain that y. Okay, so what is the order, correct order? Correct order is 0 to 1 integral over x square 2x f of x comma y. You have to change, even they are giving in the wrong order, you have to interchange y to x, x to y, so dy dx. Very simple, the inner integration variable is y, the limit should be in x. In case here, even I can write as a note here, simply you can understand. In case the inner integration variable is x, the limits should be in the terms of, should be in terms of y, in terms of y, or constant it may be, no problem, or constants. Okay, but inner integration is x, the limits also should be in x, is totally wrong. Okay, and then here we can write in okay, next we have to write that in case the inner integration variable is y, the limit should be in terms of x, is it not? So simply we can write here vice versa. Able to understand? Next one is case 3. Case 3 just we have seen now. Next we are going for the triple integral. Triple integral means, for the triple integral, already we explained that in the beginning, but once again you can say that. So here, what are the limits? Z equal to, what are the outermost integration? Z, middle integration is y, and then inner integration is x, is it not? So it is the inner integral, it is the middle integral, it is the outermost integration with respect to z. In case if we are integrating with respect to x, means keeping y and z as constant, keeping y and z as constant, the limits of that x may be that constant or function of y and z. The remaining two variables may contain. Okay, so once you integrate with respect to x, means next we have to integrate with respect to y. When you are integrating with respect to y, the limits may be in terms of the outer integration variable z or constants. When you are integrating with respect to outer integral variable z, the z limits should be that constant, it contain any other variables. Okay, is it clear? So the inequality is g1 of y comma z, that means x lies between that g1 of y comma z to g2 of y comma z are constant, and then y lies between that f1 of z less than or equal to y less than or equal to f2 of z, that may be the variable of z or constants. But that z1 less than z less than z2 is there na, where that z1 and z2 are constants, are constants. So these inequalities determine the domains in space whose boundaries are the surface here given. The domain name is called, the domain is called the domain of integration of the above triple integral. So in the class we have discussed about that case 2 and case 3, whereas case 1 is that all the limits are constant, case 2 is if y limits are constant and x limits are variables, and then case 3 is if x limits are constants and y limits are variables. Okay, then based on this we can discuss one simple problem here. We do this only one problem. Elaborately we can discuss in the next class. One simple problem we can discuss here. Okay, for example, evaluate integral over 0 to 1 and then integral over x root x xy x plus y dx dy. You can guess now. Just now I told na what is the mistake here. It is not the mistake. You can give 1 or 2 minutes time. You can identify now. See the limits. The limits are in terms of x. Inner integration variable is also x. In case if it is x means that should be in terms of y. Otherwise what you have to do? You have to change that order. Very simple solution. Therefore I equal to, we have to write in this proper order 0 to 1 and then x root x xy x plus y. It should be dy first, dx second. Are you able to understand? Okay, so just now I written as note na, in case of the inner integration variable is x, the limit should be in terms of y. In case the inner integration variable is y, the limit should be in terms of x. Is it not? See that here inner integration variable is y, the limit should be in terms of x. So how to draw that? The rough sketch for this. First you have to identify what is the shape of this limits. What are the limits of y? The limits of y are y equal to x. Y equal to x means it is the straight line. Second one is y equal to root x. Y equal to root x means squaring on both sides. We will get that y square equal to x, is it not? This is the parabola. Y square equal to x is the parabola. Okay, what is the intersection point? How to identify the intersection point? Y equal to x is given, and then second one is y equal to root x is given. Y equal to root x is given. So y square equal to x. Already here given that x equal to y, is it not? So y square equal to y, substitute here. You can take it y square, then y get cancel on both sides, then y equal to 1. If y equal to 1, x is also. So x equal to 1 and y equal to 1 are the intersection points. Are the intersection points. Is it that? So now you have to draw the rough sketch for this. How to draw the rough diagram for this? Rough diagram. No hurry in drawing the rough diagram because it is very important to draw the rough diagram in a very problem. Okay, then I don't know if to use a ruler in this. Take the shape here. Shape. Okay, fine. Y equal to x is one shape, is it not? Y equal to x, it is the straight line. Y equal to x means it is a 45-degree straight line. It is a 45-degree straight line. So you can take the straight line here. 45-degree straight line. Yes. 45-degree straight line. Fine. The second one is parabola. Parabola diagram. What is a parabola? Y square equal to x. Y square equal to x is this one is the parabola. This is the parabola. Is it not? Now see that limit here. What is the inner integration limits? Y. Is it not? So y means you have to draw the parallel line to y axis. Draw the parallel line to y axis. If you draw the parallel line to y axis, okay, see here, if you draw the parallel line to y axis, this is straight. What is the starting value? You can see the integration. It is start from y equal to x. What is the straight line y equal to x? Here, change the pen color. This is the y equal to x. The second one is y square equal to x. Is it that? It is starting from y equal to, the limit is start from y equal to x, end with the parabola y square equal to x. Therefore, it is the region. Is the region. Starting from straight line is the region of integration. Is it not? So starting from that straight line, 45-degree straight line, end with that parabola. Okay. So how to solve this? I equal to double integral over 0 to 1. And then one more important thing. What are the intersection points? 0, 0. And then this point is 1, 1. Intersection point is 1, 1. This point is 1, 0. This point is 0, 1. You can take this point as A. Fine. Therefore, we can write here x2 root x, x2 root x, xy, x plus y, dy, dx. So that is integral over 0 to 1, and then x square y square by 2 plus x y cube by 3 y equal to x, and then y equal to root x, and then outer integral is dx. Fine. We have to substitute the value, upper limit and lower limit. What you get? That is equal to integral over 0 to 1, and then x cube by 3 plus 1 by 3 x power pi by 2 minus x power 4 by 2 plus x power 4 by 3 dx. The next step, simplify this. What you get? That is equal to integral over, okay, after integral After simplification, what is the integration? X power 4 by 8 plus 2x power 7 by 2 divided by 21 minus x power 5 by 6. What is the limit? From 0 to 1. That is equal to, substituting 1 here, 1 by 8 plus 2 by 21 minus 1 by 6. So this gives that 3 by 56. This is the value of the integration. Is it not? So here I want to give some hint here. In case if you are changing the order, double integral, what happens? I equal to double integral over what is xy into x plus y, xy into x plus y is writing here dx dy here, dx dy here. Then what about the limits? And what is the answer for this? The answer will not change, 3 by 56. Okay, then what about the limit? How can we write the limit? Already, what is the inner integration variable? Y is the inner integration variable. So therefore you draw the parallel line to y-axis. Now you can see that what is the inner integration variable here? X is the inner integration variable. So draw the parallel line to x-axis. Draw the parallel line to x-axis. See in the region, this is the region, is it not? So therefore, what is the starting point? Starting point is the parabola, ending point is the straight line. But previously, starting point is the straight line, ending point is the parabola. Now if you are changing the order, means starting point is parabola, ending point is straight line in the region. So therefore, what is the parabola here? Y square equal to x is the parabola. Y square equal to x, but x equal to y square. Similarly, end with the straight line. What is end with the straight line? Straight line is x equal to y. What about that y limits? Intersection points. What are the intersection points? 0, 0 and 1, 1. You are going to write that the limits for y, is it not? So what are the y limits here? 0 and 1. So simply we can write the 0, 1, 0 and 1 here. Y equal to 0 to y equal to 1. Okay, and then you have to evaluate. Okay. So this is about the double integral if the limits are variables. Okay, in the next class we will discuss few more problems. So can I write the few problems for the practice? Problem for practice. Please you try this and then solve it. Problem for practice. First problem, integral over 0 to 2, integral over 0 to 1, 4xy dx dy. Second problem, integral over 0 to pi by 2, integral over 0 to pi by 2, sin theta plus pi d theta d pi, d theta d pi. The third problem is integral over 0 to pi, integral over 0 to sin theta or d or d theta. Then we can do only a few problems. Okay, we can add one more problem, triple integral. Please try this also. 0 to 1, 0 to 2, 0 to 3, x, y, z, dx, dy, dz. So these are the few problems for practice. In the next class, we will discuss about the order of integration and how to calculate the triple integral under some region. Thank you. See you in the next class.